Hello everyone. For the past 3 months, while balancing my workload from my internship and SURG, or the Summer Undergraduate Research Group, I've been working on creating a platform that essentially allows me to control a stepper motor in closed loop, which essentially, contrary to open loop, it basically gives the stepper motor the ability to know where it is in space. So without all this extra hardware that you see here, the stepper motor would essentially not know what position it's currently in. Directly in the middle, we have an actuator that I completely designed from scratch in the month leading up to SURG. This is all 3D printed. It is using PLA, which is a type of plastic, and this was designed in Fusion 360. Directly at the top, we have the stepper driver, and right behind it is the stepper motor. The output shaft of the stepper motor is attached to a little pulley that spins a belt, and you'll see that in a little bit here. And the belt is essentially the spins another big wheel that is the input to a big planetary gearbox, which is that big gray piece that you see there. A lot of the other material that it's sitting on is just a mount. It's not actually part of the gearbox. The whole gearbox itself is about a 30-to-1 ratio. So for 30 spins of the motor, the output spins once. And here you see the belts now attached to the stepper motor. And that drives the sun gear, which spins a bunch of planets. And then the planet gears are attached to the output. What you see here is essentially the data I'm reading from the teensy. Note that data is actually just random numbers, since I don't have the actual hardware to support that, but I still wanted to simulate what that would actually look like. In terms of the rest of the hardware on this actuator, you have the encoder, which is like top right, that circular thing with a belt attached to it. That belt is reading the output shaft. So here I'm demonstrating another piece of hardware, and that is the Hall effect sensor. So the thing to point out here is the orange line that's at the very bottom, currently reading 0. When I bring the magnet close to the sensor, essentially output's low, which turns the LED on, and you'll see in the graph in the background, you can see kind of like a square wave of the sensor reading that there's a magnet there versus not reading that there's a magnet there. And on this output shaft, attached to the back of it with some tape, is essentially a magnet that is tripping that sensor. So this is the PCB that allows me to control a stepper motor in closed loop. So this is not the actual board that I designed in Altium. This is something that I did last weekend because the boards we designed in Altium could not arrive before the expo. This does not implement all the functionality of my original board, but it gets me most of the way there. So on the left, the 4 wires, those are for controlling the stepper driver. On the right, the top right, those 4 wires coming out of the terminal blocks are for the encoder. The bottom right terminal block is the data signal from the Hall effect sensor. The very bottom, we have an OLED display. It is the SSD 1306, I believe. And then to control everything, we have a Teensy 3.2. The Teensy is communicating with the OLED display over I2C, and both the Teensy and the Arduino are receiving power over USB. What you're about to see in a few moments here is the output shaft spinning past the Hall effect sensor, and you'll see that red light up, meaning that the magnet on the back of it has triggered the sensor. And you'll see that happening right now. So I wanted to take the chance to go a bit over the code. Essentially, the stepper motor will rotate the shaft until it sees the sensor, and once it sees the sensor, it will begin to slow down to a standstill. It will delay a few seconds, and then it will speed back up. Once it reaches full velocity again, it will begin to look for the Hall effect sensor, and once it hits it, it will begin to slow down again, and it will repeat the cycle. So the next three pictures here are screenshots on my board that I created for this application. And with these in the background, I actually want to talk about the code. So in the future, what I'm going to do is I'm actually going to implement a state machine for this. I think a state machine would be perfect for a robotics application where you could have like a homing state, a normal operation state that would accept inputs from a joystick or something. And then obviously like between all the states, the sensor data would always have to be read, the encoder and the Hall effect sensor. So I think a state machine would do this application really well. And for the prototype, there's actually disco mode, which you will see now.
Feel things sometimes